Welcome back to Through Inquisitive Kids. In this video, we'll be going over the solution sets of inequalities, finding and representing solution sets of inequalities. First, we already had the introduction to inequalities, and in the last lesson, we did the properties of inequalities. Now, we're going to be doing the solution sets of inequalities. And solution sets are basically solutions to inequalities where you simplify down to the variable on one side and another value on the other side. So basically isolating the variable as well, just like you would in an equation. And then we're also going to learn how this relates to representing inequalities on the number line. And now after this will lead up to one variable inequalities in linear functions, inequalities in word problems, and methods of solving inequalities. The two learning goals for today is to understand the concepts of solutions of inequalities, solution sets, and solution inequalities. Accurately grasp the expression method of the solution set of the inequality on the number axis, and be able to correctly express the solution set of the inequality on the number axis. The concept of solution sets of inequalities. When setting off fireworks, in order to ensure safety, the person who ignites the fuse must move to a safe area 10 meters away before setting off. It is known that the burning speed of the fuse is 0.02 meters per second, which is 2 centimeters per second, and the speed at which the person moves is 4 meters per second. What conditions should the length of the fuse meet? So setting off fireworks is something that is very fun to watch and very exciting to do. But of course, there is a level of safety that you must meet before you do it. And because, if the firework goes off too early and you're still too close to it, there is a good chance that you will get hurt. So this is saying that you have to move to a safe area 10 meters away. Now this fuse melts off at 2 centimeters per second. Move away at 4 meters per second. So how long should this fuse be? Well, let's look into this together. Let the length of the fuse be x centimeters, since we don't know it yet. And the inequality we can get is x over 0.02 times 100. It has to be greater than 10 divided by 4. The time at which the fuse burns off and the fireworks explodes has to be greater than the time you take to move to a safe area 10 meters away. So simplified, in using the properties of inequalities, we learned this from the last video, we can simplify to get x is greater than 5, which means the length of the fuse has to be greater than 5 centimeters. Out of these numbers, which ones satisfy the inequality x is greater than 5? Well, this should be pretty straightforward. Out of these, it would be 6, 7.2, 8.5, and 9. 5 itself should not be included since it has to be greater than 5, not equal to. So how many numbers satisfy x is greater than 5? Don't listen to the impulse of just saying 4 because there are 4 numbers listed here. No, there's actually an infinite amount of numbers that satisfy the inequality x is greater than 5. These 4 numbers are just the 4 that we chose to write down. So our summary is that values can be substituted as the variable that satisfy the inequality. So these values are called the solutions of an inequality. All solutions of an inequality from the solution set of the inequality. The solution set of the inequality must satisfy 2 conditions. Any value within the solution set must make the inequality true, and any value outside the solution set doesn't make the inequality true. So the solution set is essentially, it contains every single value that satisfies the inequality. The process of finding solutions to inequalities is called solving inequalities. Let's do some practice. Determine whether the following statements are correct. 1. X is equal to 2 is a solution to x plus 3 is less than 4. 2. Inequality x plus 1 is less than 2 has an infinite amount of solutions. 3. X is equal to 3 is a solution to 3x is less than 9. And 4. X is equal to 2 is a solution to 3x that is less than 7. Now pause the video and fill in these blanks on your own. The first one would be incorrect, because if you substitute x is equal to 2 in, it would be 5 is less than 4, and that's just invalid. The next one is correct, because every single inequality will have an infinite amount of solutions. X is equal to 3 is a solution to 3x is less than 9. No, that is not the case, because 3 times 3 is 9, and that 9 is not less than 9. You really have to be precise with the language here. And for number 4, it would be a solution. 2 times 3 is equal to 6, and that is less than 7. Okay, so here, this should be instead a check mark. Let's continue. Solution sets of inequalities on number lines. How can you show the solution sets of inequality x is greater than 2 on the number line? Well, here is a number line. And our first step is to mark point A, which represents 2. All numbers to the right of A is greater, while numbers to the left are smaller. Pretty self-explanatory. We can see how once you go right, you get bigger, and when you go to the left, you get smaller. Solution set x is greater than 2 can be represented on the number line. And you can do it like this. And just a reminder, point A should be an empty point instead of a filled-in one to show that the solution set doesn't include the value 2. Here it says x is greater than 2, but if it were x is greater or equal to 2, then this would be filled in as well. Represent the solution sets of inequalities on the number lines. We have x is greater than -1 and x is less than 1/2. Pause the video and solve this on your own first. Alright, so for the first one, we would have x is greater than -1. Remember, if you go right, you get bigger, so this inequality, it contains everything to the right, and it doesn't include the number -1 itself because it is a greater than, so that circle is not filled in. For this one, it is less than 1/2, and it doesn't include that point in either, so it should not be filled in. Show the solution sets of x is less than or equal to 5 on the number line. So here is a number line, and we first mark the point on 5. Since it is less than or equal to, it is a filled in circle, and then everything less than that is included in the solution set. Inequality x is less than or equal to 5 includes 5, so the point representing the number 5 is filled in. Less than or equal to represents less than or equal to, and greater than or equal to, so this symbol right here represents greater than or equal to. So here is our conclusion, the method of representing solution sets on number line. First, we create a number line. Next, we have the boundary marker. If this value is included in the solution set, it will be represented by a filled-in circle. If it is not included in the solution set, it will be represented by an empty circle. Then we have to fix the direction. If it is a greater sign, we extend the drawing to the right, and if it is a smaller sign or a lesser sign, we extend the drawing to the left. Example 1. Given that the solution to linear equation ax plus 12 is equal to 0 is x is equal to 3, find the solution set to inequality parentheses a plus 2 times x is greater than -6 and represented on the number line. What integers are included in the solution set? Now, using the concepts we've learned previously in this lesson, pause the video and try to solve this question on your own. Here is our solution. We start by substituting x is equal to 3 into ax plus 12 is equal to 0, where we get a is equal to -4. Now substituting -4 into the second inequality, we get -2x is greater than -6, which means that x is less than 3. And now we have to show it on the number line. First, we create a number line, and then we first mark that boundary marker. And since it is a less than sign, we extend the drawing to the left. And now, as shown on the number line, the solution set includes integers 1 and 2. Class summary. Today we learned all about the solution sets of inequalities. We looked at simplifying to get the solution set of the inequality, as well as plotting it onto the number line. This is an example of how algebra can be converted into geometry and how these two areas of math are deeply related. It's also kind of like how you can graph equations onto coordinate planes. We will also, yes, we will be getting into inequalities on the coordinate planes as well. So stay tuned for that. Again, to summarize our learning goals. Today we understood the concepts of solutions of inequalities, solution sets, and solution inequalities. We were also able to accurately grasp the solution method of the solution set of the inequality on the number axis, and were able to correctly express the solution set of the inequality on the number axis. Thank you so much for watching through Inquisitive Kids. If you found this video helpful, please share it with a friend or click the like button.